My name is Toby Wakefield-Carl, and we're going to be looking at another practice question from the 2019 FRQ. That's going to be number 5. So here's the question. Let's see, is let R be the region enclosed by the graphs of g of x equals -2 plus 3 cosine of pi over 2x, and h of x equals 6 minus 2 times the quantity of x minus 1 squared, the y-axis, and the vertical line x equals 2. So here they give us this region, and so the first thing we're going to do is just identify the type and just the strategies that we're going to be using. And so obviously we see this region that they're giving us, so we're thinking probably going to have to be calculating the area between the curves or the volume. And for the volume, we'll either be using cross-sectional or rotational volume, depending on what they're asking us to do with it. And for the rotational volume, we'll be using the discs, washers, or shells. And as you can see in this problem, they're not specifically going to give you a shell problem per se, but you can always use shells whenever you see fit. So let's go on to part A and see what it's asking us to do. Alright, so here we go. See, the first part of this is just find the area of the region. And so this is just one of the things that we saw that we were going to be prepared to do. And so we're just going to have to come up with this interval here. We're just going to find the sum of basically all of the little cross-sectional areas, I guess, using the top minus the bottom as the length, and then multiplying by the width using this integral right here. And so let's go through simplifying. You have the upper and lower bounds between 0 and 2, and so you'll just simplify this with the any derivative, and then you'll plug in the upper and lower bounds, and it'll come out to the answer of 44 over 3. So your answer will be the area of R is equal to 44 over 3. Moving on to part B. Here we see, here's the find the volume of the solid. So this is the second thing we're going to be asked. Remember, we had both area and volume that we were going to be asked to do with this problem, and so part B is the area. And so right here it says for the solid at each x, the cross-section perpendicular to the x-axis. So they're telling us which way to slice it. We have to slice it from top to bottom pretty much. And so to find this area using the cross-section volume, we're going to have to multiply just the area of the bases multiplied by the heights of it. And so they're giving us the area of the base right here. So all we have to do is plug into this integral between 0 and 2 just to calculate the cross-sectional volume. And so just simplifying like this, and right here we see our answer. The volume of the solid is going to be ln 5 minus the natural log of 3. And so we're just going to leave it like that. That's the most we can simplify it there. Alright, moving on to part C. Here it says, write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals 6. So if we look over back at the graph, we see y equals 6 is up here. And so we notice that some parts of the graph, some parts of the region are not touching the axis of rotation that we're going to have up here. So we're most likely going to be using the shell method to calculate this. And so oftentimes on the AP, they'll ask you to write an expression on the non-calculator portions. When they don't want to calculate it, they just want to check that you understand how to do this. And so it's very simple. It's going to be right here. We have the formula of the shell method. You're just going to multiply the pi r squared. So we have the pi we can pull out of the integral out in front of the integral right here. And then we just multiply this. Obviously we have the shell method, so it's going to be this 6 minus this top line to get the area of in between those, and then 6 minus the bottom line to get the rest of that, and then we come out, and that's our answer to this question here.